to our practice test. Those of you who were tardy the other day need to get this Kleenex taken care of or are going as a detention. You don't want a detention, football players, I've heard.
Oh, damn.
So you want to bring in that full-size non-generic box of Kleenex. Okay? Make a note of it.
It's generic,
Non-generic.
I know, but what would be considered generic?
Like Mile brand or something like that. I want Kleenex or cuffs. Okay, so here we go. How much? Okay, the first question. I need everybody paying attention now because this is a GTQ, guaranteed test question. Let's get it right. Some of you already have this figured out. Wonderful. Be patient. We need everybody else to figure it out. So we have 6 numbers in the problem. The first thing I'm going to do is go through and put in all of my percentages. It's so easy. 23%, 58%, 31%. There we go. Now, the other number in the problem is 36 ounces. And it says 36 ounces of 31%. So the 36 goes with the 31. It says it in the problem. Okay? Now, this we agreed we're going to let be X because every problem starts out with how much of this. So we're going to let that be X. Now, the empty parentheses, every time you do this, there's going to be one empty parentheses, right? If the empty parentheses is here, it's 36 minus X. If the empty parentheses is here, it's 36 plus X, right? The 36 is the one amount that you know. If it's here, it's 36 minus X. If it's here, it's 36 plus X. So there is our equation. Now, does anybody have a question about that? It's going to happen that way every time. So then we multiply it out using our calculator. This is a distribute, so you're distributing here. And then we kind of collect like terms and move things around, and we have negative 0.35x equal to negative 9.72. So when I divide, I get 27.77 ounces. Okay. That's, oh, did you get into how much of that too? Okay, all right, I'll look at that. So that's 27.77 ounces. Is anyone still unclear about that setup? All right, and then the last question on the quiz. This is one of those where we've got a price, which is 4.85 in this case. And then we're doing a couple things to it. We're going to have a minus 22% because that's a discount. Discounts, sales, markdowns, those are all minuses. And then a 7% tax or a tip is an add-on, extra. So a 22% decrease goes in as what decimal? 0.78. 1 minus 0.22. Remember, if it's a discount, you do 100 minus that percent. So 100 minus 22 is 78, so it's 78%. If it's an add-on, you do 100 plus that, so your tax is always 1.07. And then we multiply it together, round off to the nearest cent. Just multiply. Just enter those numbers times in your calculator, and it's $4.05. Good? This isn't the time to just sit back and say, oh, I hate math. This is the time that we should be getting pumped up because we have a test tomorrow.
Yeah, I'm in there.
Yeah. Okay, let's look at our practice test and finish up. yesterday, I believe we did practice test 3, but only, the word problem page? Or did we start? I can't remember. Who can tell me? I think
we started the word problem.
I think we did the word problem page yesterday. Yeah, I think we're ready to go.
Let me see if practice
Where's your notes? I just want to see where I stopped. Did you take notes?
Yes.
You take notes, Paul?
We're on the practice.
Practice test.
Wait,
Yeah.
yesterday didn't we?
We did number 2, and I thought we started number 3. No, we did word problem. Okay. All right, so on practice test 3, yesterday, or the last time we were together, we did the word problems. Okay? So on the practice test number 3, which by the way, looks exactly like the test. I spread things out, I formatted it. So the test you get tomorrow is going to look exactly like practice test 3. Problems are going to be located right where they're located. It looks exactly that way. So we already did page 3, the word problems. So now we are going to do, we will start on page 1 and we'll just work our way through. So here is the first problem. How do we find the inverse? What are you going to do? This is problem 1 on the test. How do you find the inverse? Switch the y and the x. And then get y by itself. Subtract 7 and divide by 4. So you will put in the answer blank this right here. This is what goes in the answer blank. Actually, it says F inverse already there, so you'll just write x minus 7 over 4. X minus 7 over 4. That's all there is to it. Curving, you're not going to miss that, right? No, that's an easy one. Now, B is a little bit more complicated, but we have practiced it enough. Nobody should miss this one either. What are the steps? Flip X and Y, just like before. This one's a little bit harder, though, because there are 2 Y's, and we're going to have to deal with that. What's our first step? Multiply this over to here, so we have to multiply and distribute. So I might want to write it down. So I have 3xy plus 4x equals 2y minus 1. Get the y's on the same side. Somebody back there knows what's going on. Good job. Once we've rearranged the problem so the y's are on the same side, Paul?
Take out the y.
Take out the y. We're going to factor it out. So we'll be left with 3x minus 2. And then we're almost done. You're going to divide. So where it says G inverse, you're going to write negative 4x minus 1 over 3x minus 2. Because you're simply dividing both sides by 3x minus 2. And that is what goes in the G inverse answer blank. Okay? Number 2. Okay, it's a 2-part question. It says, given the picture that I have sketched there, is the inverse a function?
No.
No. Why?
It doesn't pass the horizontal line
It doesn't pass the horizontal line
test.
test. Remember, if we want to know if the function itself is a function, that's the vertical line test. But if we want to know about the inverse, look at question A. You see how it says, is the inverse a function? The answer is no, because it does not pass the horizontal line test. See those lines there? You write out. It does not pass the horizontal line test. Now, I am going through right now and labeling all of my ordered pairs that are on the original picture. That's just the original picture that I drew there. And I've just labeled the ordered pairs. Why have I done that? Because I'm getting ready to sketch the inverse. And when I sketch the inverse, what do? I switch the ordered pairs. So 0, 0 stays the same. 1, 1 stays the same. But 2, 0 will become 0, 2. So there's my triangle. It used to look like that. Now it looks like this. -1, -1 stays the same because I'm just switching it. But this becomes -1, -2. And this becomes 0, -3. And there's a picture of the inverse. Now, should you miss that problem? No. Just reverse the ordered pairs. Nothing tricky or hard. Reverse the ordered pairs. Now, 3 is a little bit unique. Create your own function that is not 1-to-1. Okay, what does it mean to be 1-to-1? It passes both tests. So you're simply going to draw anything you want that doesn't pass both tests. So what kind of shape are you thinking? Triangle. I would maybe just draw the absolute value because I want it to be a function. So the b maybe? Is that 1-to-1? No, because it does not pass the horizontal line test. So that would be a perfect example. So would a parabola, right? Parabola. Okay? Lots of different possibilities. All right, next page. Do not be confused by this. This is probably the easiest question on the whole test. It says x is 3 minus 4t, and y is 6 plus t. Now you're going to let t be -2, find the ordered pair. So that means find x and y. Well, what are we going to do? Plug -2 in. So we're going to have x is going to be 3 minus 4 times -2. What's that equal? 3 plus 8, so that would be 11. And then 6 plus -2 would be 4. You're going to have a calculator for this whole test. I wish you didn't need a calculator on a problem like this, but if you do, put in -2 so you get the right answer. Okay? Now 5 is a little bit harder than that. It uses the same idea, parametric equations, but it's a little bit harder. Does anybody remember how we approach a problem like this? Huh?
You plug in extra one, or like.
Well, we're going to do that, but before we do that, we have to get t by itself. So pick one of your equations. I would probably pick this one because it's easier. And I'm going to get t by itself. So what will t equal? Y over 3? You're dividing, right? Y over 3? Now, take this t value and plug it into your x equation. So you'll have x equals 1 plus 6 times y over 3. So in one of your equations, get t by itself. Then plug that t value into the other equation. Now simplify. What's 6 times y over 3? 2y. 6 over 1 times, times 1 over 3. That's 2y. Now, you can leave if you leave that as your answer, I'm not going to mark it wrong. It would be better to write it this way because that's just the normal way we write lines. But if you can get this far, I'm not going to mark it wrong. Marley?
So, are you not supposed to get t by itself in both problems and cross multiply?
You can get t by itself in both problems and set them equal to each other? Absolutely, that will work. That will always work also. This is substitution. I'm kind of using the substitution method here. You're using it, it's fine.
Okay.
Totally fine. All right, number 6. This is one of those you really have to pay attention to what's going on, okay? So we're looking at number 6, and let's just make a list of what changes we see. So look carefully at the picture. What are some changes that you see in going from 1 to 2? Flip sideways. I'm just making a list now. I'll put it in an equation. Flip sideways, up 1. Is that all?
Absolutely.
No, I think it's just picked up 1. That's it? All right, so we only have 2 things going on. So your baseline equation is this. We're going to put numbers or negatives or pluses or something into this equation. How do we flip it sideways? Negative in the parentheses. So you're going to have a negative right there. A negative on the x is what flips you sideways. How do you move it up 1? You add 1 outside, right? Plus 1. And that's the answer to the question. Everybody good? Number 7, are these inverses? You remember what we do here? What do we do here? Pick a number, some random number. Don't pick 1 or 2 or 0 or something special.
4.
Pick some random number.
7.
7. Love 7. All right, so pick 7. What happens if I plug 7 into this guy right here? What do I get if I put 7 in here? I get 9. Everybody good with that? Now, take that 9 and put it in right here. What better happen? If they're inverses, what will happen? You get your 7 back again. So if 7 became 9 in one function, then 9 has to become 7 in the other function. So if I put in 9, I get 9 plus 5 over 2. What is that? 7. So the answer to the question is yes. Okay, then you got these lines. Why or why not? Because when I plugged 7 into F, I got 9. And when I plugged 9 into G, I got 7. Okay? Now, what if you used a different number than 7? What if you put in 10? Then 10 would give you 15. And then you would put 15 in here and you'll get 10 back. That's the key. The next page we've already done, that should already be all filled in for you. Those are our word problems. Quick comment about the box, just so you remember. Remember when you write the equation for the box, it's always dimension minus 2x, dimension minus 2x times x. And the domain is always 0 less than x less than half the smallest. Half the smallest. Sounding familiar? Okay. Number 11, just because we haven't talked about it yet today, this is percent of increase. How do we do percent of increase or decrease? We take the difference divided by the original. So you figure out how they're different, subtract them, how much different are they, and then whatever that number is, you divide it by the original. All right, now we're going to graph. This is exactly what your test looks like, people. It is identical in format. So the back page of your test is going to be some weird shape. This one is a triangle that looks like this, and a tiny little trapezoid that looks like this, and then a tall trapezoid that looks like this. All right, so that's my baseline picture. So A says f of the absolute value. All right, so what happens when we take the absolute value of the x? That's a mirror. That mirrors the right side onto left. So mirror right onto left. So my right side is my big trapezoid. So there's my big trapezoid on the right side. And then that's going to get mirrored onto the left side. What happens to all this? It's gone. Just gone. Disappears. That's the answer to part A.
I can't remember. Is there ever a special case where the mirroring would be at the left side?
No.
It would mirror the left side?
No. Now, we can reflect the whole thing, which means we can put this over here and all of this over here, but there's none of this mirroring type thing. All right, now B is another absolute value, but the absolute value is around the whole problem. So what happens when we put the absolute value around the whole problem? Bottoms up. Anything on the bottom goes up. So my big trapezoid stays right where it's at. He's on top already, he stays there. My triangle stays right where it's at. It's on top, it stays there. The little trapezoid, though, is going to flip up because it's underneath on the bottom and it has to come up. What do you think? Is that okay? All right, let's do C. All right, now we got a couple of things happening in C. Can anybody tell me what's happening in this problem?
Upside down and right one.
Upside down and right one. So we're upside down and we're right one. So I'm going to do the right, I'm going to do these in two separate steps because I can't keep track of it. So I'm going to do the right one first. So everything is getting moved to one unit to the right. So here's my trapezoid now, my tall trapezoid. And here's my triangle. And here is my little trapezoid. So everything has been moved one unit to the right. Does that look okay to everybody? Now I'm going to turn it all upside down. So there's my trapezoid. Here's my triangle. And here's my big trapezoid. One unit to the right and upside down. So far, so good? All right, I'm making a lot of room for this next one. Why am I making a lot of room? This guy is going to be 3 times as wide as he was before. Because we've hooked this to the X, it does the opposite. So it's 3 times as wide. How about the negative? Across, well, I'll say sideways flip. Okay, so here we go. Here we go. So 3 times as wide and sideways flip. So that means my big, tall trapezoid will be over here now. But in the beginning, it was how wide? Oh my gosh. So now it's going to be 9. 9 wide? All right, so here we go. My big trapezoid now is 9 wide. So it's still 3 tall, but it's 9 wide, so it's all stretched out. So I come over 3 and plot a point, over 3 more and plot a point, and over 3 more and plot a point. Now my triangle used to be 2 wide, so now it's 6. And you may not even have room for the trapezoid. Because it is now 9 units wide. So I count over 3 and plot a point, and over 3 more and plot a point, and over 3 more and plot a point. And there it is. Sideways flip. 3 times as long. Everybody okay? All right, one more. 2 things are happening in this problem. What are they? It's half as wide and twice as tall. So this is twice as tall and this is half as wide. So this one's going to be tall and skinny. So I'll start with my big trapezoid. It's going to go up to 6 now. But instead of being 3 wide, it's only going to be 1.5. So there's the end of it right there, 1.5. This guy is very tall and skinny. So there's my tall, skinny trapezoid. Now what about my triangle? He was 2 wide, so now he'll only be 1 wide, and he goes all the way up to 4. So there's my tall, skinny triangle. Remember, I'm doing both of these at once. If you need to do them in steps, that's perfectly okay. So if you need to make it twice as tall first and then shrink it, that's fine. How about my little trapezoid now, down trapezoid.
1.5.
1.5 wide, so he's gonna stop right here, and he's too tall. So he's coming down like this. There he is. 1.5 wide and down 2. What do we think? Are we okay? All right. We are going to take the last couple minutes now, and we're going to talk about any of these problems that you feel like you want to practice an extra one of. Okay? That's the test. So what do you feel like you might miss? Because as much as I want it, I don't think I'm going to have all perfect papers. I hope I do. What do you think you might miss that you're a little unsure of? Marley?
Can we do the amount times percent?
Yep. Yep. So we're going to do another mixture. We call those mixture problems. So we're going to do another mixture problem. That's all for the next unit. Now, no, that's the practice test. Okay, that's what we're working on now. The other 3 that I gave you are for the next. Okay. All right, so here's the problem Marley wants to do. How much 52% solution needs to be mixed with 8 gallons of 70% solution to get 61% solution? Here's the question. This isn't on any paper anywhere. Marley asked to do an extra practice. Here we go. So we have amount times percent plus amount times percent equal to amount times percent. Have we ever set it up any different than that? No. Set it up that way. Then you've got 6 numbers that you're going to be multiplying and adding. Fill in your percentages first. 52, 70, 61. What goes here? X. Now, somewhere you have to put in the 8. Read the question.
With the 70.
8 of 70. So it goes right here. Now, when the empty space is on the end like that, that means we're adding these together, and this is going to be 8 plus X. If the 8 had gone here, then this would be 8 minus X. So 0.52X plus 5.6 equals, distribute 0.61 times 8. Now I'm going to subtract my 0.52, so I got 0.09x. I'm going to subtract my 4.88. I get 0.72. Oh my gosh. I made this up, and it's going to work out nicely, isn't it? So x equals 0.72 divided by 0.09. If I divide both sides by 0.09. And the answer is 8 gallons. Okay?
Good stuff.
Anybody else think of something? We have time. I'm not going to let you go early. We're going to use this time. Paul?
The calculator problem.
With the box.
We just did one.
No. The Y-min and Y-min.
Oh, actually finding, okay, so on this test, the only time you're going to do that is with a box problem. So let's suppose that we had a piece of paper that was 30 by 50. And we're gonna make a box, so you know we're gonna cut out the corners, this never changes, these are X. What's our volume?
50 minus 2x.
50 minus 2x.
30 minus 2x.
30 minus 2x.
X.
X. That's my volume. What's my domain? Now, and this is important because when I set up my calculator, this is my X min and X max. So what's my domain? 0 less than X less than 15. Half the smallest dimension. So now I go to my calculator and I do two things. Before I press graph and all that, don't press graph. First, put this equation in, y equals. You've already got an equation in there, you're gonna have to put in this one. All right, so I got the equation in. Then go to window. X min is 0, X max is 15. What's Y min? 0. Volume can't be negative, so 0. What's Y max? We don't know, right? Right? So I'm just gonna press graph. All right, I don't see the top of my mountain. All right, you gotta see the top of your hill, right, Paul? I don't see it. So I'm gonna go back to my window and I'm gonna make Y max a lot bigger. I'm not even close in my picture. That didn't work either, so I'm just making it bigger and bigger and bigger. Almost. I got it, almost. I'm using 5,000. 5,000 gives me a nice picture. So for Y max, I had to go all the way to 5,000 to see this on my screen. Now that's the point I want. Okay, so if you haven't seen a parabola yet, let Y max be 5,000. Okay? Now, how do I find the maximum? Because that's what the question is. How do I find the maximum? Second calc. Go down to maximum, because that's what you want. Put the cursor on the left side. Put the cursor on the right side. Put the cursor on top of the mountain. And you're going to get a point. And the point is 6.07, comma, 4104.41. Morgan?
What does it mean, like, put the cursor on the left side?
Because when you press second calc and then you press maximum, the cursor comes on the screen and it says left bound. So you gotta move the cursor so it's on the left of the point you're looking for.
It's always 0 less than half.
So, we need an answer to the question, which I never even asked the question, so you don't know. If we wanted to find the maximum volume, the answer is 4,104 cubic inches. What does the 6 represent? The size of the corners that we cut out of the paper to fold up the box. All right, I'll see you tomorrow. We're gonna have a test.
So percent increase to do
The difference over the original.
over the original from the original being
Yep. Fish mode has been off. Any other extended